6 extrinsic muscles, so those are the muscles that move the eyeball around but are not inside the eye. 4 of the muscles are controlled by the ocular motor nerve, cranial nerve number 3. Cranial nerve number 3 also is important part of the parasympathetic division because it controls some of the intrinsic muscles of the eye to change the shape of the pupil and also the shape of the lens. The 2 muscles not controlled by the ocular motor are cranial nerve number 4, the trochlear. Trochlear means pulley. And the abducens nerve, cranial nerve number 6, that controls the lateral rectus. So abduction means you're going to contract this lateral rectus muscle and the eye will move outward. Okay. We have 3 tunics. We have the fibrous tunic, very tough. The front of it is clear, the cornea, except when the animal's preserved, and then the sclera. Inside, we're going to have the vascular tunic, lots of blood vessels here. It has an iris that surrounds the pupil. It has a ciliary body, which has ciliary muscles in it, and also processes that make the aqueous humor. Inside, we have the retina. Notice it doesn't go all the way to the front. The retina, once you take out the vitreous humor, which is in the back, the posterior cavity, this retina may detach. It looks kind of whitish gray. This is where we find the photoreceptors. So in the front of the eye, in front of the lens, made by the choroid processes, ciliary processes, is aqueous humor. Behind the iris, we call it the posterior chamber. The aqueous humor then moves out, around, and then is eventually reabsorbed into the sclerovenous sinus, also called the canal of Schlemm. I like that name. If that gets blocked some way, that can lead to glaucoma, which can lead to blindness. So it's very important to have the test for that. Okay. Now, light waves coming in are bent as they go from one type of medium to another. The first thing bending the light rays is the cornea, then the aqueous humor. The pupil doesn't do anything to bend the light rays because it's just a hole. The lens can change shape and bend the light rays more or less depending upon, if you're looking at something up close, you need to bend the light rays more because they're diverging and you want to make them converge back on the retina. The vitreous humor also bends the light rays. Now, when we hit the photoreceptor layer, the neural layer is where we have all our photoreceptors. That's the innermost layer. It's nourished by the choroid. And we have 2 types of receptors there, rods and cones. The rods are for vision in dim light. The cones are for vision for color vision, vision in bright light, and they don't work at night. And they're also for visual, for looking at things sharply. The greatest concentration is in an area called the macula lutea. In the middle is a little depression called the fovea centralis. That's where we have the highest concentration of cones. When you look at something, you tend to look at it so that the light falls right on that spot. There aren't many rods there. At night, you should look off-center if you want to see well because there aren't many rods. The rods are towards the periphery. Now, the funny thing is the light will go through all these layers to get to the photoreceptors. So the rods and cones are actually the 3rd layer down. We stimulate them, the message is passed back from the rods and cones to the bipolar layer and finally to the ganglion layer. The ganglion cell layer, its axons leave the eye at what we call the optic disc or blind spot because there's no receptors there. And that's our cranial nerve number 2, where the axons of that ganglion cell layer. So there's a lot of problems that can go wrong with the eye. If it's a very short eyeball, that can cause farsightedness. If it's a very long eyeball, you would have nearsightedness. If you have uneven curvature in either the cornea or the lens, that could be astigmatism. As you get older, the lens isn't able to change shape as well for near vision. That's called presbyopia, old eyes. And that means you've lost your ability to what we call accommodate. Now, when you look at things up close, we have to bend the light rays more. We have to do a number of things. One of the things that happens is the lens gets fatter. It accomplishes this because the ciliary muscles contract, and they're circular muscles, and that loosens the ligaments that attach to the lens. So the lens actually gets fatter when you look at things up close. That's going to bend the light rays more. Also, the pupil gets smaller, so it gets rid of some of those diverging rays. We also tend to look, get a little bit cross-eyed when we look at things. That's called convergence, when we look at things up close. And let's see, what else? One more thing. And the refraction I already mentioned to you.